Evaluating limits just numerically from a table isn't going to give you the whole picture. So a lot of times periodic functions like trig functions are going to give weird repeating patterns which aren't seen if you don't pick the right values to put in your numerical table. So here's an example, cosine pi over x. Even though if you pick values in the table, if you pick the wrong x values, you'd think, oh, the limit's 1. But looking at the graph, you'll see the limit is not 1 because the graph's values keep bouncing between 1 and minus 1 the closer you get, infinitely many times the closer you get to x equals 0. So even though a table and a graph give you a good idea of the limit of a function, and in this section you're going to be asked to find limits that way, and you're going to say they're equal to that, finding them algebraically, which we'll see in the next section, is really the way to get a definitive answer. So let's talk about when that value of L is not a finite number. So in this case, the limit doesn't exist, and they're called infinite limits. So here's 1 over x squared, and you can see the limit as x approaches 0. If I approach from the right, all my y values are getting larger and larger without bound. If I approach from the left, the y values are getting larger and larger without bound. So since they aren't approaching a finite number, this limit doesn't exist. So we would say that the limit, use the symbol infinity to describe this case. Remember, infinity is not a number. So this hopefully dusts off your memory about vertical asymptotes. So when a function approaches infinity as you're approaching an x value, or negative infinity, you have a vertical asymptote. So in this case, the vertical asymptote is 0 because the y values are approaching negative infinity. They're being made large negative. In my previous slide, they're approaching positive infinity. Again, the vertical asymptote was x equals 0. Here's f of x equals 1 over x minus 5. Same thing, same graph. I just shifted it over 5 to the right. The vertical asymptote is x equals 5. The limit does not exist. Here's another good piecewise function. So for which values of a does this limit exist? So since the limit's approaching, as x approaches 0 from the left, the y values are approaching 1. And the same as x is approaching 0 from the right. So even though this function is not defined at x equals 0, this limit exists and is equal to 1. The other possibility, looking at this piecewise function, is when x is pi. So as x approaches pi from the left, the y values are approaching negative 1. But as x approaches pi from the right, the y values are approaching 0. So since the limit from the left doesn't equal the limit from the right, the limit as x approaches pi does not exist. So we'd say the limit exists for all values except when x is pi. When a is pi. Here's another example. Use a table of values to estimate this limit. So you can see this is clearly not defined at 4, but if we pick values of x closer and closer to 4 from the left and from the right, you can see the y values look to be approaching 0.25.